define your given values based on the problem. Okay, so let's take for example that we ought to determine the balance parameters PB, MB, and EB. So we assume PB is located somewhere at the grid 2 near the upper corner. So we don't know where PB is because we are solving EB. Okay, so but the thing is, I want you to assume that the bending is about the horizontal axis passing at the plastic centroid. So your PB is somewhere along this grid line here, very near to this upper corner of your triangle. Okay, so I will mark it later. I cannot mark it here in Excel. So as what Jerome did, uh, he computed the plastic centroid. So I don't know the others if they have get they have gotten the same answer here. So 84.8877 is the value of your YP. So it is imperative to always compute first for your plastic centroid location. But if your section is symmetrical and the shape is also symmetrical, then the geometric centroid is the same as that of the plastic centroid. It's easy to locate it. Okay. So how about the balance parameters? I want you to look into my Excel now. So you define your given values from FC prime up to the steel area here, and it's better to use the name, the definition of your name. Let's say FC prime. So you have to define. Just right click your cell and then define the name. For easy of formula computation, so I can now write here FCU. Okay, I don't know if prime can be accepted. If I use FC prime, it will not be accepted there. So you might as well use the variable FCU, meaning to say that this is the ultimate compressive strength of your concrete. Okay, so this already exists. Name should be unique. Where is this? Is it already defined? I don't think it's defined here. Hmm. So we cannot place the same name. I already erased it. Anyway, we might as well use the cell formula. We can also use the name as D39 there, but better if it is named definition. Okay, so let me cut this first. Let's try again. So FCU. Can place the name. Cut and paste here. So let's close this one. So I can paste the name here. This is a cut and paste file. Anyway, let's just use the cell, no? The cell name, which is, let's say for this, it's D39, etc. Okay. So I can now make use of the formula for CB. What's the formula for CB? So it's 600 times D1, or sorry, D2. Okay, always the D here for CB is the last. Okay, the last distance defined by the steel layer. So if you have only two layers, you placed here uh, D2 or 435. Okay, so this is a D42 divided by 600 plus Fy, and Fy is D40. Okay, so let's just use the cell name. Can place a variable name there. Okay, for AG, the area of the gross is only the area of the compressive block defined by the plastic centroid location. Okay, so this is now simply a measure of your depth of stress block. Okay, so we know that the depth of stress block is simply beta 1. Okay, or we cannot use beta 1. So this is beta 1 times CB. Okay, CB. Okay, so multiplied by the width B. Okay, 300. So this is now your AG. Okay, for AS1, we simply multiply the area of a 25 number of bars. Let's say 490 times the number of bars at the layer. Okay, so this is also equal to 490 times 1, and same is true with this one, 490 times 1. Okay, so everything now is given. So these are the things that we need to use in our table. Okay, if you are going to look at the table has three stresses, and the distance is added, no? So the table is not the same as the table for the plastic